All right, so chapter 7, we're going to learn about ways to solve polynomial equations. At this point in your life, you're very, very good at solving linear equations. Let's say I gave you 2x plus 3 equals 5x minus 9. How do I look at that equation and immediately know that that equation is linear? That's true. There's only one variable, and there's no exponents on the variables. So that's what we would call a linear equation. And like I say, at this point in your life, I know that everybody in this room is very, very good at solving that equation. How do you solve that equation? You get all the x's on one side, you get all the numbers on the other side, and then you divide. And you said subtract 2x. It doesn't matter if you put the x's on the right or the left, does it?
No, I just like keeping the x's positive.
You like keeping the x's positive when you can? That's not a bad thing. So you would have 12 equals 3x. And then you divide by 3x is 4. All right, so linear. We've done lots of linear equations already in this course. Like I say, I know you're all experts at linear equations, no problems there. So what we're going to be looking at in this section is we're going to be looking at nonlinear equations. So for example, I might give you x squared equals 4.
Take the square root.
Well, first off, why is that nonlinear?
Because there's power.
Because there's a power. That makes it not linear. You're telling me I take the square root, and you would tell me the answer is
2.
x equals 2. And I would tell you you're half right. Plus or minus. Why negative 2?
Because it's positive or negative.
Because negative 2 times negative 2 gives me positive 4. All right, so there's a huge difference right there, isn't there? Linear equations. How many answers? 1. This linear equation had exactly one answer. Nonlinear equation, this one already has 2. So there's a huge difference to begin with. Nonlinear equations are usually going to have multiple answers. Not always, and we'll see some examples later where not always have multiple answers, but usually have multiple answers. That one has 2. X equals 2 equals x equals negative 2.
Would you want to written like that? Would you like x equals plus and minus 2?
I would accept either. That means the same thing. X equals 2, x equals negative 2. You can also write it as x equals plus or minus 2. The only thing I will warn you on is that MyLab does not accept that notation. If you're doing your homework on MyLab to get that extra credit, which hopefully you're doing, it will force you to write it as 2 answers like that. But as far as I'm concerned, on a quiz or a test or a worksheet or whatever you're doing, you can write it like that. I'd be good with that. All right. So before we can talk about how we solve nonlinear equations, we have to play a game. No, we're not going to play Hangman. Here's the game. You're going to pick your favorite 2 numbers in the whole wide world.
7.
You can't tell me.
I mean,
You're going to pick your favorite 2 numbers in the whole wide world, and I'm going to tell you one of your numbers.
right now.
Huh?
Right
I am. You ready? So pick any 2 numbers in the whole wide world. When you multiply your 2 numbers, the answer is 0. So pick 2 numbers. When you multiply your 2 numbers together, you get 0.
This is no.
And then you have to pick 2 numbers that when you multiply, you get 0.
You're always going to get it because
That's how I'm always going to know one of the answers. One of the answers has to be
0.
0, doesn't it? How can you multiply 2 numbers together and the answer come out to be 0? You have to multiply by 0. That's the only way. All right. That actually has a fancy math name. That's called the zero multiplication property. And it says if you multiply 2 things together and your answer is 0, then what has to happen? One of them has to be 0. Do we care which one? Could both of them be 0? Okay. If a times b equals 0, then A equals 0 or B equals 0 or both. Both would be okay too, but in particular, one of them has to be 0. That's called the zero multiplication property. All right, so here are the rules to solve nonlinear equations. Step 1, get everything on one side. Zero on the other. So notice right away that's very, very, very different from linear. What do we do for linear? We get all the x's on one side, all the numbers on the other. For nonlinear, you get everything on one side, all the x's, all the numbers. As I was saying, for linear, our first step is get all the x's on one side, all the numbers on the other. For nonlinear, our first step is get everything on one side, all the x's, all the numbers, everything. Step number 2, factor. And again, you might have wondered, why did we spend so much time in Chapter 6 learning how to factor? Well, here's another reason we factor. When we factor, what are we going to have? What does factor mean to do? I might take out the common factor. I might have a trinomial and write it as two pieces. But the thing is, when you factor, you have things that are multiplied together, don't you? So after we factor, we're going to have things multiplied together, and they're going to equal 0. So that's going to take us back to the zero multiplication property. If we have two things multiplied equal 0, one of them has to be 0. So step 3 is use zero multiplication property. And step 4, what Sterling said, is we were going to have two equations. Solve the two equations. Okay, so again, the key is the process is very different from linear. Linear you do one way, anything nonlinear you do completely a different way. All right, so here's an example. X squared minus 3x equals 10. First, you need to recognize that that is nonlinear. What makes it nonlinear? It has a square. It's definitely nonlinear as a power. Our first step is get everything on one side and 0 on the other. So, minus 10 on both sides. Okay? X squared minus 3x minus 10 equals 0. You remember this. Good. We factor. So we see a trinomial. Trinomials factor as two binomials, so it's x minus 5 and x plus 2. And now again, this is the whole key. We are multiplying two things, this times that, and we're getting 0. And your final answer is x equals 5 and x equals negative 2. The only way to multiply two things together and get 0 is one of them has to be 0. So you're skipping a step, which is fine. Once you do a few of these, you start skipping this step. I'm going to write it down just to be very clear on what's happening. Thank you, Dave. All right, so these two things are being multiplied. They're equal to 0. That means one of them is 0 or the other one is 0. And then you're right, those are very simple equations. We can solve them in our head. We add and subtract as appropriate. X equals 5, x equals negative 2. So once again, we get, with our non-linear equation, we get two answers. Questions on that? All right. How about, let's steal some good ones out of the book here. (16) x squared equals 8x. Say that again.
Minus the 8x.
Minus the 8x. Again, you notice it's got a square. It's not linear. So we get 0 on one side. 16x squared minus 8x equals 0. Get the 0 on one side. Can we factor 16x squared minus 8x?
Yeah, you can take out and make that.
I can take out an 8x as my GCF. All right, so 8x left over. 2x minus 1.
Then when you set it to 8x equals 0 and then 2x minus 1 equals 0.
8x equals 0. 2x minus 1 equals 0. This one gives you x is
-8.
not negative 8.
And 0 over 8.
0 over 8, which is a fancy way of saying 0. We divide both sides by 8. 0 over 8 is 0. So x is 0 is one answer. And over here, you would add the 1 and then divide by the 2. X is a half. Once again, 2 answers. All right, how about x squared minus 6x plus 9 equals 0? Already has 0 on one side, doesn't it?
Yeah.
That's nice. All right, so I guess we factor. X minus 3 and x minus 3 again. So we kind of get 2 answers, but it's really only 1 answer, isn't it? Because we get x equals 3 twice, and normally when we get the same number twice, we would only list it once. So that's the rare time that can happen. It is possible to start with an equation that has an x squared, and you really only get 1 answer. That doesn't happen very often. It only happens when this factors as itself twice. So what you should expect, anytime you see an equation with an x squared, how many answers should you expect to get? You should expect to get 2. What if you start with something that has an x cubed? How many answers would you expect to get? 3. Why 3? Because there's 3 x's, basically. All right, so let's say I gave you something like x cubed minus 5x squared minus 24x equals 0. You should look at that, and again, you should recognize that it's nonlinear. It has powers. You should look at it and notice it has an x cubed, which tells you you're probably going to get 3 answers. Factor out a GCF first. Take the x out. Then you have x squared minus 5x minus 24. And then you can factor more. So you take the x, and then you factor more. Factors as? X minus 8x plus 3. All right, well, our 0 multiplication property said if you're multiplying 2 things together, one of them has to be 0. What if you're multiplying 3 things together and you're getting 0? One of them still has to be 0, doesn't it? And again, do we care which one? No.
So x equals 0, x equals 8,
X is 0, x is 8, x is negative 3. So again, if you start with an x cubed, you should expect to get 3 answers. All right, now let's go to the fun ones. X over 2 plus 1 over x minus 3 equals 3. Subtract the 3.
or you can get rid of the fraction.
And that's a mistake. Just ignore that. That's a plus. I wrote an equal when I was supposed to write a plus. That's what that is.
So should we just times both sides?
No, we should times both sides. I notice I have an equation. My equation has fractions. I want to get rid of those fractions.
Right. Would you want to put the 3 over first?
I wouldn't put the 3 over first. Not to clear the fractions. I would just leave it right where it is.
Right.
So what are we multiplying by?
X minus 3.
So our common denominator is 2 times x minus 3. 2 times x minus 3. 2 times x minus 3. And remember to do it over here too. And that's an easy one to forget. That 3 is not a fraction. But if we multiply, we have to do it everywhere. It's a common thing people forget right there. They forget to multiply that one. All right, so the 2 wipes out with the 2. And that looks like x squared minus 3x. The x minus 3 wipes out with the x minus 3, so that's just a 2. And here, this one becomes 6x minus 18 when we distribute through. All right, so really nothing different there. We saw an equation. The equation had fractions. We started by getting rid of them. Now we go into this is nonlinear mode because it has an x squared. So what am I going to do? Get everything on one side, which tells me subtract 6x, add 18. X squared minus 9x plus 20 equals 0. Then factor it. Okay. X and x. Minus 5 and minus 4. Okay. So x is 5, x is 4. Are both those answers okay? Yeah, how come? Because the bottoms would not equal 0. And this can happen, so watch out for this again. Notice right here, I crossed it off, it's hard to see. We started with an x minus 3. So if one of these answers had come out to be 3, I'd have to cross it off. And that can happen sometimes. Sometimes you have to cross off one answer and keep one. Here's a good example where we get to keep both answers.
And that was if x was minus 3?
X was positive 3 because it started with an x minus 3 down on bottom.
Oh, right.
So if x had been 3, 3 minus 3 would be 0. So watch out for that. Here's a good example where we get to keep both the numbers. That happens. Sometimes you get to keep one and cross one. Sometimes you're going to cross them both out. Neither one of them work, which tells you that there's no solution. That can happen. Okay? So you got to go back again and check. And again, you don't really have to plug the number in and make sure it's working. What you really need to do is make sure you're not getting 0 down on bottom. We don't get 0 down on bottom here.